Okay, so we are going to look at permutations. We already touched a little bit on this in some of the applications in section 5.1, but now we're going to get a nice formula that's going to summarize really specific things that actually do happen quite often. So the formula, just call it the P formula. Some people will use the word pick, but I don't recommend that. It stands for permutation. So if you have n distinct objects and you wish to arrange R, exactly R of those objects, so without repetition is really important. You can do so in exactly NPR, so that's one notation that's often used. It really just depends on your calculator, what book you're reading. Or you might see it as P bracket N comma R, that's a little easier to type out. But the formula is going to be this n factorial over n minus r factorial. So I'll explain why in this example here. A lottery ticket consists of 4 different numbers from 1 to 20. Your ticket wins if it has all 4 numbers in the correct order. How many distinct tickets are there? So there's a little bit of language that I really want you to pay attention to. So here I've said to arrange. So when we say arrange, that implies that order matters. So we'll see some other problems later where you'll be asked to just choose R objects, and you could like put them in a bag and jumble them together. So in this case, we're going to arrange R objects, so order matters. And then it's stated here that your ticket wins if it has all 4 numbers in the correct order, which means that, in fact, order matters. And that tells us we're going to use the P formula. And so how many distinct tickets there are. So as far as this ticket is concerned, or as far as determining if you're a winner or not, the tickets are distinct if they have different numbers. They could have the same numbers in a different order. So obviously if they have different numbers, they're different, but if they have the same numbers in a different order, they're also different. So basically what this is asking us is how many orderings of the numbers are there. So how many ways can we order those numbers 1 from 20? And some other really useful piece of information to keep track of here is it also does say 4 different numbers. So that also means that there's no repetition. So again, that is something else that we do need for the P formula. And so we just need to, actually what I'm going to do is not even use the P formula. What we can do is try to solve it without the P formula, just to show you how the formula works. And so what we'll do for this is just break this into the tasks. It's 4 numbers. So we're going to look at the number of possibilities for the first number, the number of possibilities for the second number, the number of possibilities for the third number, and the number of possibilities for the fourth number. And between these tasks, it's a then statement. So we pick the first one, then we pick the second one, then we pick the third one, then the fourth. So it becomes multiplication. And so what we'll see here is the first one, we can pick any of the 20. And then for that next number, there's only 19 left. Now 2 are gone, so there's 18 left. And now 3 are gone, so there's going to be 17 left. And so what we're going to, I can calculate that, but 20 times 19 times 18 times 17, we get 116,000. It's fairly high. And 280. Okay, so now if we try to solve this with the P formula, so what we're going to have here is the number of distinct objects. So there's 20 distinct objects. And we're arranging 4 of them. So what it's going to be is that's n is 20, r is 4. So we have to plug this in the formula. I'm going to use whichever one is set on my calculator, which is probably the NPR one. So I'm going to have 20, P4. So how you're going to type this on your calculator Maybe I'll move that so I can write it above it. So what we're going to write is you're going to hit the 20 for the first number. You're going to hit that shift or second button or whatever you need to do to get to your secondary functions. And it could be anywhere on the calculator, but it's almost guaranteed to be a secondary function. And it'll probably look like a little NPR up there. And then you're going to hit the 4, and then you'll hit equals. And we should get the exact same number. The 116280. Now, how we're going to see why we get the exact number is if we actually go back and use that formula directly as it's written, if I want to avoid using the calculator. So what I'm going to do here is just get rid of the question, because I think we should be accepting that that's the answer right now. All right, so we want to see how this works, how this formula actually works. If I were to plug it in there, what I would have is, so that n is 20, so that's going to be 20 factorial divided by 20 minus 4 factorial, which is 20 factorial over 16 factorial. And if we actually sort of pull this apart, I'm not going to write all the numbers up to 20, but what I am going to do, I'm going to get a whole bunch of cancellation. So I'll skip a bunch, and if I do the 16, I'll expand that across the bottom. And so what we can see is I will get a lot of cancellation. Everything cancels. I can cross them out by dividing basically all of the terms except for those last ones here. So basically by doing that 20 minus 4 factorial, what it's going to do is cancel out everything but the last 4 numbers in that permutation. And so it's going to leave you with exactly what we've got over here on the left. So it just sort of does it for you without having to write out all of those slots.